All right, everyone, let's start the paper. October, November, um, November 2024, variance 43, IGCSE O-Level, paper 4. Let's start the paper now. A list of substances is shown. Answer the following question using only the substances from the list. Each substance may be used once, more than once, or not at all. State which substance is manufactured by fermentation. Glucose, ethanol is manufactured by fermentation through glucose. So I'm going to write ethanol. Next is monatomic. Monatomic means consist of only one atom. So all noble gases consist of only one atom. In other words, we can say that all noble gases are monatomic. So let me check if we have any noble gas in the list. Helium is the right option. Is a reactant in photosynthesis. Photosynthesis involves the reaction of carbon dioxide and water, converting into glucose and oxygen. So carbon dioxide is given. So I'm going to write carbon dioxide. Examiner has given us the name. So we need to write the name in the answer instead of formulas, okay? Is a solvent in the extraction of aluminum. The solvent was molten cryolite. Cryolite is given. Is an ore of iron. Hematite ore is the ore of iron. Hematite is given. So hematite is the ore of iron. Is manufactured from methane. Is manufactured from methane. So is manufactured from methane. Methane cannot give ethane, cannot give ethanol, cannot give ethene, cannot give graphite, helium, hematite, hydrogen, silicon dioxide, sodium chloride, bauxite, cryolite. But yes, carbon dioxide is formed. When methane is burned in the presence of excess oxygen, carbon dioxide is formed, which means we can manufacture carbon dioxide from methane. Let's move on to the next. Is a compound with giant covalent structure. Giant covalent structure has diamond, graphite, silicon dioxide, and silicon, right? Let me check. This is silicon 4 oxide is given, so I'm going to write silicon 4 oxide. Is used as a lubricant. Graphite. Graphite is given, yes. Graphite is used as a lubricant. Is tested for with lime water. Carbon dioxide. One more thing. Is manufactured from methane. से क्या चीज मैन्युफैक्चर हो सकती है? Oh my goodness, that's very, very important. When methane and steam react together, then you would get carbon monoxide gas and hydrogen gas is given off. So from methane, we can manufacture hydrogen gas. That's called steam reforming process. We have done that process in energy changes का chapter, right? So carbon dioxide भी produce कर सकते हैं, hydrogen gas भी produce कर सकते हैं. Hydrogen gas अगर given है तो हमें उसको भी लिखना है. Yes, it's given. So let's write hydrogen also. Okay. Hydrogen or carbon dioxide. Okay. Both are possible. Carbon dioxide is formed when methane is burned in the presence of excess oxygen. All right. I hope it makes sense to you. That's the end of question number 1. Let's move on to the next question. This question is about electrolysis. State the meaning of the term electrolysis. Electrolysis is basically the decomposition, in fact, the chemical decomposition of compound by the passage of direct current. It's called electrolysis. Okay. Next, table 2.1 gives information about the electrolysis of two electrolyte using graphite electrodes. So examiner is using graphite electrode for these two electrolytes. The first one is concentrated aqueous potassium iodide. Now, in this scenario, we have potassium ion and hydrogen ion. We have iodide ion and hydroxide ions. All right. Well, hydrogen ion discharge at cathode in the form of hydrogen gas. And since the concentration of iodide is greater than hydroxide ions, which is why it will discharge first from the electrolyte in the form of iodine, and that discharge at anode, okay? Whereas hydrogen discharge at cathode. So at anode, name of product is iodine. And obviously, iodine has a brown solution. So I'm gonna write brown solution in the observation. At cathode, bubbles of colorless, odorless gas is given off, and that gas needs to be hydrogen gas. Now we have another electrolyte, which is aqueous copper 2 sulfate, which means we have copper ions, we have hydrogen ions, we have sulfate ions, and we have hydroxide ions. You know, it's a dilute solution, which means hydroxide ion discharge first from the electrolyte in the form of oxygen gas at anode, whereas copper ions discharge first at cathode in the form of copper metal because it is closer to the line of discharge. Okay. So oxygen gas is given off. That's the case. And pink brown solid appears at cathode, and that pink brown solid is basically copper. Next is complete table 2.1. We did that. Oxygen is produced at the anode by the electrolysis of aqueous copper 2 sulfate. Ionic half equation for this reaction. Okay. 4 hydroxide ions will turn to 2 moles of water, 1 mole of oxygen, and 4 electrons. Okay. Aqueous copper 2 sulfate is electrolyzed using copper electrode. This time it is copper electrode, which means cathode and anode both are made up of copper electrode instead of graphite electrodes. Explain why mass of anode decreases during this electrolysis, since anode is made up of copper and at anode oxidation takes place, which is why copper electrode dissolve itself. So copper electrode dissolves due to oxidation at anode. Name the product formed at the cathode. Obviously, copper. Okay. Next, state what change, if any, is observed in the appearance of the aqueous copper to sulfate. When we used graphite electrode, then the blue solution fades during the course of the experiment. But when we replace graphite, when we replace copper electrode from graphite, then the concentration of copper ion in the electrolyte remains same throughout the experiment, which is why the color of the electrolyte will remain same, which means there is no change. There will be no change in the color of electrolyte because the concentration of copper ions will remain same. Okay. Let's move on to the next question. This question is about compounds of tin. Tin has a symbol of Sn, capital S, small n. Tin is found in group 4 of the periodic table. Tin 4 oxide has a formula of SnO2. The relative formula mass of SnO2 is 151. So MR of SnO2 is given. Calculate the percentage by mass of tin in SnO2. So in order to determine the percentage by mass of tin, we need to find out the relative atomic mass of tin from the periodic table. So let's move on to the periodic table. Let me check what sort of mass is given. Tin. This is group 4, this is tin, and tin has a mass of 119 and its atomic number is 50. So 119 is the relative atomic mass. 119 divided by MR, which is 151. Since we have only one tin atom in the formula, so into 1 we kar dete hain. And since we need the percentage, so multiply with 100. So it's basically 119 divided by 151. So it's basically 78.80%. So it's going to be 78.8%. Okay. SnO2 is an amphoteric oxide. Amphoteric oxide means can react both with acid and alkali. SnO2 reacts with aqueous sodium hydroxide to form a sodium salt and water only. The sodium salt contain a negative ion with a formula of SnO32 minus. State the meaning of the term amphoteric. Can react both with acid and alkali. Okay. To form salt and water. Write the symbol equation for the reaction between SnO2 and NaOH. So this is SnO2 plus NaOH. Look, it is the sodium salt, right? And that's very, very important point. It is the sodium salt in which the formula of negative ion is SnO3 2 minus. So we have sodium ion, which has a charge of +1. We have SnO3 2 negative ion. So if charges are different, obviously these charges cross multiply with each other. So the formula becomes Na2 SnO3. So that's the formula of sodium salt. So I'm going to write it. अंदाजा हुआ होगा कि मैंने किस तरह से सॉल्ट को डिटरमाइन किया. Na2SnO3, and obviously hydrogen and oxygen combine together to give water. Now how many sodium here? 2 sodium, so I'll put 2 here. How many hydrogen here? 2. How many hydrogen here? 2. Total oxygen here on this side is 4. यहाँ 3 है, यहाँ 1 है, तो यहाँ पर भी oxygen balance. So tin balance, sodium balance, oxygen balance, water balance. So that's the balanced chemical equation. Okay. By the way, examiner पूछ नहीं रहे, लेकिन मैं फिर भी बता देता हूँ. This compound is called sodium stenate. The name of that salt is sodium stenate. Okay. Tin is a metal that forms both covalent and ionic compound. Suggest why this is unusual for the metal, because ये metalloid है, so it shows both metallic and non-metallic character. Because metal only forms ionic compound, whereas this metal forms covalent compound as well. Because tin is an amphoteric, tin is basically the metalloid, which is why it shows both metallic and non-metallic property. Because metals only forms ionic compounds, while this metal, okay, while tin also forms covalent. That means it is metalloid, because metalloid shows both metallic and non-metallic character. Metalloids. Okay. Next page. Tin 4 chloride SnCl4 is covalently bonded. Obviously, tin is found in group 4 of the periodic table, which means it has 4 covalent bonds, or it forms 4 covalent bonds. This is the first chlorine, this is the second chlorine, this is the third chlorine, and this one is the fourth chlorine. So this is the formula of tin 4 chloride SnCl4. A tin atom has 4 electrons in its outer shell because it is found in the 4th group of the periodic table, which is why. Complete the dot and cross diagram in the molecule of SnCl4. By the way, tin contains 4 valence electrons. Chlorine is found in group 7 of the periodic table, which means it has 7 valence electrons. So let me distribute tin first. 1, 2, 3. This one is 4. Let's talk about chlorine. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So that's the case. Tin 2 oxide SNO is ionically bonded. The melting point of SnCl4 and SNO are shown in the table 3.1. Obviously, SNO has the highest melting point SnC as compared to SnCl4. So examiner is looking for the explanation in terms of structure and bonding why SnCl4 has a much lower melting point than SNO. Oh, because SnCl4 exhibit covalent bonding and has a simple molecular structure. With weak van der Waals forces, less energy is needed to overcome such forces. S and O has a giant ionic lattice with a strong electrostatic attraction. So more energy is required for this. More energy is required to overcome such a strong force. Okay. Next is part of the reactivity series is shown. When aluminum foil is added to aqueous tin to sulfate, a reaction does not occur even though aluminum is above 10 in the reactivity series. Okay. Now the question is why reaction does not occur? Because aluminum is more reactive. So it reacts with atmospheric oxygen so that a protective oxide layer is formed. Because of that protective oxide layer, aluminum cannot react with tin to sulfate. Okay. Aluminum reacts with oxygen in air to form a protective oxide layer. Okay. Hence cannot react with tin to sulfate, which is SnSO4. An aqueous solution of tin to sulfate contain 2 plus ions. 2 experiments are carried out. In experiment 1, copper 1 is added to aqueous tin to sulfate. Magnesium is added to aqueous tin to sulfate. Write an ionic equation for any reaction that occurs in each experiment. If no reaction occurs, write no reaction. Copper is less reactive than tin, obviously, which means no reaction. And magnesium is more reactive. So obviously, equation is going to be like this. Mg plus SnSO4 arrow MgSO4 plus Sn. Obviously, Mg will remain as it is. Tin 2 sulfate ionizes into its tin 2 plus ions and sulfate ions. Magnesium sulfate ionizes because it is soluble in water into its magnesium ions and sulfate ions. Tin metal will remain as it is. Now the spectator ions cancel out with each other. So the final equation going to be like this: magnesium plus tin 2 plus ions, arrow magnesium ions plus tin metal. Examiner was looking for the ionic equation, okay, not the molecular one. Hydrated tin 2 nitrate decomposes when it is heated. State what is mean by the term hydrated. Hydrated means water of crystallization is present. Compound is combined with water of crystallization. Okay. Next is complete the equation for the decomposition of this compound. So when this compound is decomposed, obviously it will convert into tin 2 oxide, nitrogen dioxide, and oxygen in water. So how many tin here? 2. So I will put 2 here. How many nitrogen here? 2 times 2. 4 nitrogen. So I'm going to put 4 here. How many hydrogen atoms here? 20 times 2. 40. 40. So 40. Hold on. 20 times 2. Charles. Oh my goodness. 20 times 2, 40, 42, 40 times 2, 80. So it has to be 80 hydrogen atoms here. So I'm going to put 40 here. 40 times 2 is 80. So tin balanced, hydrogen balanced, nitrogen balanced. Let's talk about oxygen now. 3 times 2, 6, 6 plus 2, 12, 12 plus 20, 32. Let's check. 4 times 2, 8, 8 plus 2, 10, 10 plus 2, 12, 12 plus 40. 12 plus 40 is basically how much? 52. Hold on, check. Let me check one more time. This is 40 and this is 2, 42, 42 and 8, 50 and then 52. Let's check. 3 times 2, 6. 6 2 is 12, 12 plus 20. I think it's balanced. 10 2, 10 2, 2 and 2, 4 nitrogen, 4 nitrogen, 20, 40 hydrogen, 40 and times 2, 80 hydrogen. So 40 times 2, 80 hydrogen. So technically it's balanced chemical equation now. That's the end of this question. Next, question number 4. This question is about sulfuric acid, H2SO4. By the way, sulfuric acid is a dibasic acid because it donates only 2 hydrogen ion in aqueous medium. Dilute sulfuric acid and aqueous sodium hydroxide are used to prepare sodium sulfate crystals using a method that involves titration. So whenever soluble salts needs to be crystallized, that involves the titration process according to my lecture. So the apparatus for titration is shown. Okay. So in this apparatus, this is burette, this is conical flask. Burette contains dilute sulfuric acid, while conical flask contain 25 cm cube of aqueous sodium hydroxide, which has a concentration of 0.1 mole per dm cube. So I know the concentration and volume of NaOH, and I've got the volume of dilute sulfuric acid from this burette. Okay, so thiamol thalene is used as an indicator. We have discussed this indicator in the class. State the color change of the thiamol thalene at the end point of this. Since conical flask contains sodium hydroxide, so when we put few drops of thiamol thalene indicator into this conical flask, obviously blue color is observed. When you treat this solution with sulfuric acid, obviously it's going to be colorless. Suggest why universal indicator is not used for this titration. I've told you that universal indicator is a mixture of different indicators, and that shows and that changes its color from pH to pH, so we cannot get the sharp endpoint. So universal indicator is a mixture of different indicator which changes their color from pH to pH, so we cannot determine the endpoint. All right. Okay, next. 25 cm cube of aqueous sodium hydroxide of concentration 0.1 mole per dm cube is neutralized by 20 cm cube of dilute sulfuric acid. So the burette reading was 20 cm cube for dilute sulfuric acid. So at 20 cm cube, we have got the endpoint. Okay, equation is given already. That equation is important because that equation shows both NaOH and sulfuric acid has 2:1 ratio. Anyway, let's talk about the number of moles of NaOH used. That's easy. We know the concentration, we know the volume, we can find the moles. So 1000 cm cube of NaOH contain 0.100 moles. If we have 25.0 cm cube moles, 0.1 into 25 divided by 1000. So it's going to be 2.5 into 10 to the power minus 3 moles. Deduce the number of moles of H2SO4. So we know that NaOH and H2SO4, both of them has 2:1 ratio according to the equation. So if we have calculated 2.5 into 10 to the power minus 3 moles, obviously moles of H2SO4 is going to be twice. Oh, not twice, divided by 2. So it's going to be 1.25 into 10 to the power minus 3. Now in the next part, calculate the concentration of H2SO4. By the way, in 20 cm cube, we have got this much moles, right? So that's going to be 0.0625 mole per dm cube. Okay. Next, a student is provided with an aqueous solution of sodium sulfate. Describe how to prepare pure sample of sodium sulfate crystals from this solution. Okay, first of all, make the saturated solution by removing the water from it. So heat the solution so that water is removed. And then solution becomes saturated. Once the solution is saturated, we need to cool the temperature at RTP. Leave the solution. At RTP. To make crystals. Wash the crystals with warm water. Not warm water, in fact, cold water. With cold water and dry them on filter paper. Potassium hydrogen sulfate KHSO4 can be prepared by reaction between aqueous potassium hydroxide and dilute sulfuric acid. What is the only other product? Write the symbol equation. So potassium hydrogen sulfate, so potassium hydroxide and sulfuric acid are reacting together, converting into potassium hydrogen sulfate and water. So beta ये तो equation बहुत easy है because examiner has given you the reactants and the products, and it's a balanced chemical equation also. Okay, let's move on to the next page. Potassium hydrogen sulfate dissolves in water to form solution X. Solution X contains potassium ion, hydrogen ions, sulfate ions. Name the type of solution that contains hydrogen ions. Obviously acidic solution. State the observation when the following tests are done. A flame test is carried out on X. Since X has potassium ions, so it will show you a lilac color. So lilac flame. Because of potassium ion. Next is solid copper to carbonate is added to X. When solid copper to carbonate is added, and obviously this solution has hydrogen ion, which is basically an acidic solution. So this acidic solution reacts with this copper to carbonate and produces effervescence of carbon dioxide. So first observation is that this copper to carbonate dissolves. Second observation, when it is treated with an acidic solution, obviously effervescence is given off. Okay. And obviously copper to carbonate is insoluble in water. But when it is treated with this acidic solution, it will turn to aqueous copper 2 ions. And aqueous copper 2 ions has a blue color. So obviously blue solution is formed. So copper to carbonate, is green. When it is treated with an acidic solution, it will turn to aqueous copper 2 ions. And aqueous copper 2 ions has a blue color. So blue solution is formed also. Aqueous barium nitrate acidified with dilute nitric acid is added to X. Since X contains sulfate ions and you are adding barium nitrate, obviously you are going to get white precipitates of barium sulfate. Okay. Next, 0.325 gram of zinc is added to dilute sulfuric acid, which contain 0.01 moles of H2SO4. The equation for this reaction is shown. Determine whether zinc or H2SO4 is the limiting reactant. Explain your answer. So we know the moles of H2SO4. So first of all, we need to find out the moles of zinc and then we can decide. So moles of zinc 0.325 divided by 65. 65 is the AR of zinc. 0.325 divided by 65, you will get 5 into 10 to the power minus 3 moles. And moles of H2SO4, 0.0100. Okay. Now, obviously, sulfuric acid is the limiting reactant. No, इसके मोल्स ज्यादा हैं, जिंक के मोल्स कम है, तो जिंक इज बेसिकली द लिमिटिंग रिएक्टेंट. ओके, आप इस तरह से भी लिख सकते हैं, मोल्स ऑफ जिंक is lower than sulfuric acid, hence it is a limiting reactant. Okay. Next, in another experiment, 48 cm cube of hydrogen gas is produced. The experiment is carried out at room temperature and pressure. Calculate the number of molecules in 48 cm cube of hydrogen gas measured at RTP. Whew, okay. First of all, let's find the moles of hydrogen gas. So it's 48 cm cube divided by 24,000. So I'll get the moles. 48 divided by 24,000. So I'll get the moles. Moles is 2 into 10 to the power minus 3. Moles of hydrogen molecule. Examiner is looking for the number of molecules of H2 at RTP. So in the next step, 1 mole of H2 occupies 6.02 times 10 to the power 23 molecules. So when we have 2 into 10 to the power minus 3 moles, so molecules would be into 6.02 exponent 23. So it's going to be 1.20 into 204 into 10 to the power 21 molecules. Okay. So answer after rounding off 1.20 into 10 to the power 21 molecules. That was a lengthy question because this question has 20 marks. Let's move on to the next question, guys. Question number 5. This question is about rate of reaction and equilibrium. The student investigate the rate of decomposition of aqueous hydrogen peroxide. That's what we have done in the class. That's the experiment we did in the class by using manganese 4 oxide as a catalyst. By the way, manganese 4 oxide is a formula of MnO2. बेटा यही हमने experiment class में भी किया आपके साथ. Okay. Next, the equation for the reaction is shown. Okay, the student uses the apparatus shown in figure 5.1. ये आपका इलेक्ट्रॉनिक बैलेंस है, ये आपका हाइड्रोजन पेरोक्साइड है, ये मैग्नीज 4 ऑक्साइड कैटलिस्ट है, और ये आपने कॉटन वूल प्लग इन की हुई है. ठीक है, और आपने इस पूरे का मास वे कर लिया है बिफोर एक्सपेरिमेंट. ठीक है, और जैसे ही आप इसको इसमें ऐड करेंगे तो स्टॉप वॉच स्टार्ट करेंगे ऑब्वियसली, और जब आप स्टॉप वॉच स्टार्ट करेंगे तो फिर आप टाइम नोट करेंगे और फिर मास वे करेंगे एट डिफरेंट टाइम इंटरवल. ओके, सो ये मास का डेटा आ गया एट डिफरेंट टाइम इंटरवल. सजेस्ट व्हाई द मास डिक्रीजेस एज टाइम इंक्रीजेस. ऑब्वियसली मास इंक्रीज हो रहा है, टाइम डिक्रीज हो रहा है, इसलिए क्योंकि ये ऑक्सीजन गैस स्लोली एंड ग्रेजुअली इस कॉटन वूल से बाहर चली जाएगी. सो ऑक्सीजन गैस इज escaped from this blast via loosely fitting cotton wool, which is why mass decreases. Because oxygen gas is escaped from the conical flask. Okay. Next, after a certain time, the reaction stops. Explain why the reaction stops. Obviously, the entire hydrogen peroxide has been decomposed. All H2O2 has been decomposed or used up. Suggest why it is not possible to use the result in table 5.1 to determine the exact time when the reaction stops. Because जो आपने टाइम इंटरवल लिया हुआ है वो डिफरेंस ऑफ 30 सेकेंड्स है, और इतना टाइम डिफरेंस जब होगा तो जाहिर सी बात है आप एग्जैक्ट टाइम नोट डाउन नहीं कर सकोगे, राइट. उसके लिए आपको शॉर्ट इंटरवल ऑफ टाइम्स चाहिए सो दैट यू कैन डिटरमिन द एग्जैक्ट time when the reaction stop. This is because large time intervals was used during the experiment. So for exact time, we need lower time difference, closer time difference data for the graph. Figure 5.2 shows a graph of the mass against time. Experiment is repeated at a higher temperature. As temperature increases, kinetic energy increases, collision frequency increases, rate of reaction increases. When rate of reaction increases, obviously that curve is going to be more steeper, like this one. Okay. Explain in terms of collision theory why the rate of reaction is higher at high temperature. Oh, that's what we have done. Okay. At higher temperature, kinetic energy is higher. Movement of molecules increases. This increases frequent collision. So collision frequency increases. So rate of reaction increases. Okay. So sketch the line expected when the experiment is repeated at a higher temperature. देखो दो तीन चीजें यहाँ पर. पहली बात, जब टेम्परेचर ज्यादा है तो रेट ऑफ रिएक्शन भी ज्यादा होगा. So if rate of reaction is higher, obviously रिएक्शन को कंप्लीट करने के लिए जो टाइम है वो शॉर्टर हो जाएगा. और तीसरी बात, all the conditions are remain same, which is why ये ग्राफ सेम लेवल पे जाकर कनेक्ट होगा. ग्राफ level of at the same point. सही है. So examiner is looking for the sketch line or expected sketch line. Okay. So इस तरह से लिख सकते हैं. Okay. That is the case. And just label it at higher temperature. Okay. Oh, let's move on to the next part of the question. Manganese 4 oxide is a catalyst in this reaction. Explain the meaning of 4 in manganese 4 oxide. This 4 is basically the oxidation state. I've told you so many times in the class. Bracket में जो भी चीज होती है, जो भी नंबर होता है, वो oxidation state होता है. Oxidation state of manganese. State how the mass of the catalyst has changed, if at all, at the end of the experiment. So obviously there will be no change in the mass of the catalyst because catalyst at the end of the reaction will recover as it is. Okay. No change in the mass. Because catalyst recovers as it is at the end of the reaction. Nitrogen monoxide gas and oxygen gas react to produce nitrogen dioxide gas at room temperature. The equation for the reaction is this. By the way, forward reaction is exothermic. So when NO and oxygen gases are passed into the beaker as shown in figure 5.3, explain why method shown in 5.3 will not allow the reaction to reach equilibrium. Because it is an open container, gases escape कर जाएंगी यहाँ से. Because for equilibrium you need a closed container, you need a closed system. To reach an equilibrium, we need closed system. Okay. the apparatus is changed and equilibrium is reached, the temperature of the equilibrium system is then increased and the position of equilibrium shifts to the left. Exactly, that's what we have done in the class. Since it is an exothermic reaction, so if we increase the temperature in exothermic reaction, equilibrium favors towards left hand side. Suggest why the position of equilibrium shifts to the left. Because when you increase the temperature, absorption of energy increases. So to neutralize the absorption of energy, equilibrium favors to the left hand side because it favors the endothermic reaction. Why the position of equilibrium shifts? Because reverse reaction is endothermic. So increasing temperature, absorption of energy takes place. So absorption of energy occur as temperature increases, which is why it favors towards left hand side. By the way, I'm saying forward reaction is exothermic. So in class, I've told you if forward reaction is exothermic, obviously the reverse reaction would be endothermic. So when you increase the temperature, reaction always favors the endothermic one. When you decrease the temperature, reaction always favors the exothermic one, okay? And that's exactly we have done in Haber's process also, okay? Let's move on to the next part. The pressure of the equilibrium system is then increased. State the direction, if any, in which the position of equilibrium shifts. Explain your answer. To determine the effect of pressure, we need to find out the moles of reactants and products at equilibrium. हम सब जानते हैं कि we have total 3 moles here. And we have total 2 moles here. So if pressure is increased, obviously equilibrium favors towards product side because of the less number of moles, okay? Okay. Okay. Equilibrium favors towards right hand side. Explanation: because of less number of moles on the product side. Next question, question number 6. State the meaning of the term hydrocarbon. Consists of carbon and hydrogen only. Consist of carbon and hydrogen only. Propene is basically an alkene, can be made from long chain alkanes such as decanes. Decane contain 12 carbon atoms. So let's apply CN H2N plus 2 formula. We have 12 carbon atoms. So 2 times 12 plus 2. So it's going to be C12 H26. So C12 H26 is the molecular formula of dodecane. Name the type of reaction that occurs when the long chain alkenes are converted into shorter chain alkenes. That's called cracking. Propene is unsaturated hydrocarbon. Why it is unsaturated? Because it contains double bond between the carbon atom. Propene reacts with bromine. State the meaning of the term unsaturated. Contain double bonds between carbon atoms. Write the molecular formula of the product form when propene reacts with bromine. So this is your propene. We have done that in class. और हम इसको ब्रोमीन से रिएक्शन करवाएंगे. सो एक बॉन्ड रिमूव हो जाएगा और इन दोनों कार्बन एटम के ऊपर ब्रोमीन अटैच होगा. यानी डबल बॉन्डेड कार्बन एटम्स पर ब्रोमीन अटैच हो जाता है और एक बॉन्ड रिमूव हो जाता है, राइट? सो इसका फॉर्मूला क्या बनेगा? वी हैव 3 कार्बन्स because examiner is looking for the molecular formula, not the structural formula. So 3 carbons, we have 3 plus 1 4 plus 2 6 hydrogen and 2 bromine atoms. So that's the molecular formula of product. Next, a styrene molecule is represented as shown. Okay, the molecular formula of styrene is C8H8. Determine the empirical formula of styrene. Since it has C8H8, so अगर मैं इसको 8 से divide करूंगा तो it's going to be CH because empirical is the simplest formula. हम इसको इस तरह से भी देख सकते हैं C8H8 divided by 4, so it's going to be C2H2 divided by 2, so it's going to be CH. हम इस तरह से भी देख सकते हैं. Okay, styrene can be polymerized into polystyrene. Polystyrene कब आप यूज करते हैं? कॉफी वगैरह के लिए, चाय वगैरह के लिए. State the type of polymerization that occurs when styrene is converted into polystyrene. Since styrene has double bond between the carbon atom, which means it undergoes addition polymerization. Draw the structure of one repeating unit of polystyrene, include all the atoms and all the bonds. The C6H5 group should be represented as C6H5. Okay, that's easy. This is carbon atom. This is carbon atom. This is hydrogen, this is hydrogen, this is hydrogen, and this is C6H5. Okay, I hope it makes sense to you. That's the end of this paper, guys.